Let us now go to the third question. It is, in Millikan's oil drop experiment, an oil drop carrying a charge Q is held stationary by a potential difference of 2400 volt between the plates. To keep a drop half the radius stationary, the potential difference had to be made 600 volt. What is the charge on the second drop? Options are 1 Q divided by 4, 2 Q divided by 2, third Q, and the fourth is 3Q divided by 2. In Millikan's oil drop experiment, there will be two charged metal plates. There will be two charged metal plates between which potential difference is maintained. In the first case, he says potential difference of 2400 volt is maintained between the plates. It keeps an oil drop of radius r stationary. You agree that the drop will remain stationary if the gravitational force, rather the weight, is balanced by the electrostatic force. You know that if the potential difference between the plates is 2400 and if the plate separation is d, electric field between the plates is 2400 divided by d is the electric field. Then if the charge on the plate is q, then if the charge and the drop is q, then the force acting on the charge is 2400 divided by d multiplied by q. This must be equal to the weight of the drop. If you consider the weight of the drop, if the radius is r, volume is 4 divided by 3 pi r cube into rho will give the mass into g will give the weight. Therefore, electrostatic force is balanced against the weight, hence the drop is stationary. If there is another drop with a radius half, if it should remain stationary, we are required to find what is the potential difference between the plates. Let potential difference between the plates be phi. Plate separation again being d, it is divided by d. Suppose the charge and the drop is q dash. This is the electrostatic force on the drop. This must be equal to the weight of the drop. Coming now to the weight of the drop, 4 divided by 3 pi. If the radius becomes r by 2, then you agree that r cube would become now r cube divided by 8. Rho into g will not change. Therefore, in the first case, balance equation is given here, and in the second case, the balance equation is given here. If you divide one by the other, you can now look at it that d and d will cancel. But in the second case, he has given that potential is 600. Therefore, V can be replaced by 600. 600 into 1, this is going to be 600 into 4. 4 upon 3 pi r cube rho z, 4 upon 3 pi r cube rho z will cancel. On account of that reason, you can easily notice that 4q divided by q dash is equal to this divided by this will give you 8. 1 divided by 1 by 8 will give you 8. 4 will cancel with it, will give you 2. Therefore, q dash is equal to q divided by 2. Hence, second option is the correct answer.